Alright, so this is 9.2, Arithmetic Sequences and Partial Sums, Day 2. The first thing we're going to cover is the sum of a finite arithmetic sequence, and that is something that's going to have n terms, and it's going to be given by this formula right here. So example number 1 says find the sum of all the odd terms from 1 to 19. And we're going to go ahead and start by writing that out. So all the odd terms are 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. And so basically what we're going to do is we're going to find a1, which is 1, and then an, which is the last term. And then we're going to find how many terms we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have n equals 10. And we're just going to plug it into that formula right there. So Sn is equal to 10 divided by 2, 1 plus 19. And then that's going to be 5 times 20, which is 100. So the sum of all these numbers is 100. All right, the next one is find the sum of all the integers from 1 to 100. So those we are not going to write out. That's going to be, but I could just kind of say 1, 2, 3. And we could say 98, 99, 100. So I need to add up all those, or I need to find the sum of all those terms. And again, we're going to use the formula Sn equals n over 2, a1 plus an. So here's our a1, here's our an, and then how many terms do we have? From 1 to 100, there's 100 numbers. So n equals 100, and we're going to plug everything in now. Okay, so we're going to get 50, oops, that should be 0, times 101, and then that's going to give us 550. So the sum from 1 to 100 is 5050. All right, part B says find the sum from 1 to n. So in this case, I'm going to go ahead and write out. You have 1, 2, 3, and minus 1, n, and so, or capital N. Okay, so then our first term is still a1, our last term is now n, and then the numbers from 1 to n are going to be n. So n is equal to capital N. I know that's weird, but if n was 10, then we would have 10 numbers added. If n was 50, then we would have 50 numbers that we have to add. So now we could go ahead and plug it into our formula. N divided by 2, and then 1 plus n, and we're just going to go ahead and distribute that in. Okay, and what is really cool about this last formula that we found is, in other words, if I want to now find all the terms between 1 to 50, I could just plug in 50 for the n here and here. So that's the cool part about that formula. All right, example number 3 says find the 150th partial sum of the arithmetic sequence 5, 16, and 27. Well, 150 partial sum means the sum from 1 to the 150th term. So we have to find the first term, which we already have, 5, and then we have to find the 150th term. So we could find that by finding the formula here. So formula of arithmetic sequence from the previous section was a1 plus n minus 1 d. So then d here is going to be, d is going to be 11 because you have to add 5 to 16 to get 11, and 16 you have to add 11 to get 27. So d would be 11, and then we already know what the first term is, so we could plug it in. And then since what we're really trying to find here is the 150th term, I'm just going to plug in 150 now and not simplify because I'm not required to find the general formula. Okay, then I'm going to plug that into my calculator and I get 150th term is 1,644. So now we could go ahead and use the sum formula. And the number of terms is 150 because from 1 to 150th term, there's 150 terms. Then A1 is 5, and then our last term was 1,644. So we're just going to go ahead and add those. So this gives you 75 times 1,649. Multiply those together. And this is the number we get. So the sum of the 150th partial sum of this sequence is this number right here.